Hey guys, welcome to chapter 7. Uh, in this chapter, we're going to talk about measuring costs, which costs matter, in the long run and the short run, long run versus short run cost curves, production of two outputs, dynamic changes in costs. One of those is the learning curve, which is pretty interesting. When you think about that concept, and we'll get to that, you want to think about that in the context of you hire someone, how long until like they're really good at their job and efficient, and then how long are they at 30% capacity, 50% capacity, 80% capacity. And then some of the concepts and examples talks about a law school choosing a new building, sunk, fixed, and variable costs, short run costs of aluminum smelting, which is the manufacture of aluminum, the effective fees and input choices, reducing the use of energy, Tesla's battery costs, economies of scope, and then the learning curve in practice. So there's a few different costs we'll cover here. So first, we have the accounting costs. Those are the actual expenses plus depreciation charges for capital equipment. Then there's the economic cost to a firm for utilizing the economic resources in production. Uh, also think about opportunity costs associated with the opportunities forgone when a firm's resources are not put to their best alternative use. Like, what could you have done differently? So, right now in the investment world, the opportunity cost is investing in like the safest government bond, a T-bill, which will get you 5%. So when you think about opportunity costs, you ask yourself, am I going to get more than 5%? And if not, I should just do the T-bill, right? Economic cost and opportunity cost are effectively the same concept. Sunk costs, that's the expenditure that has been made and cannot be recovered. Because a sunk cost cannot be recovered, it should not influence the firm's decisions. For example, specialized equipment for a plant cannot be converted. For alternative use, the expenditure on this equipment is a sunk cost. So, you think about, for example, um, someone builds a Top Golf somewhere, right? You build a Top Golf golfing facility, doesn't really have any other use cases, right? That's a sunk cost. If you go out of business and someone else takes over, they're probably going to tear the building down because no one else can use it for anything else. Next, location for a law school. Um, Choosing the location for a new law school building. So it talks about Northwest Mutual University. Law school has long been located in Chicago along the shores of Lake Michigan. And then effectively, they had a thought about building a new building in a more cost effective area, that was away from the main campus. Does this argument make economic sense? No, it makes the common mistake of failing to appreciate opportunity cost. From an economic point of view, it is very expensive to locate downtown because the opportunity cost of valuable real estate is high. That property could have been sold for enough money to buy the Evanston land with substantial funds left over. In the end, Northwestern decided to keep the law school in Chicago. It was a costly decision. If you think about that, maybe for ego they kept it in Chicago instead of a little bit outside the city. But when you think about a prestigious law school, they probably don't need to be in the most expensive area. And the reason for that is like, people who want to go to the fancy law school are going to go to the fancy law school. Location isn't really a factor for the buyer. They're going there for prestige. Uh, Measuring the cost, which costs matter. So this total cost. Total cost is made up of two components, fixed and variable cost. Fixed costs do not vary with level of production. So think about like you rent out a facility that makes something, some piece of electronic equipment. Doesn't matter how many you produce. Your fixed cost, whether you're renting that room or renting that factory. So you might want to just try to maximize that space, right? But you also have variable costs that vary with output. So you think, some of the costs that vary with output are kind of whatever your ingredients are or your inputs. The only way that a firm can eliminate its fixed cost is by shutting down. This is actually really important when it comes to the oil market. A lot of times people pumping oil will often keep it open while it's losing some money because the cost to turn off the oil is so high. It's like a big engineering feat. So they'll lose money a little bit for a while before they decide to shut off the pump because of the cost, the fixed cost of actually shutting down the oil pipeline. Shutting down doesn't necessarily mean going out of business. By reducing the output of a factory to zero, the company could eliminate the cost of raw materials and much of the labor, but it would still incur fixed costs of paying the factory's managers, security guards, ongoing maintenance. The only way to eliminate those fixed costs would be to shut the doors completely. How do we know which costs are fixed and which are variable? Over a very short time horizon, most costs are fixed. Over such a short period, a firm is usually obligated to pay for contracted shipments of materials. Over a long time horizon, say 10 years, nearly all costs are variable. Workers can be replaced by machines, managers can be laid off. Fixed versus sunk cost. Fixed costs can be avoided if the firm shuts down or even goes out of business. Sunk costs, on the other hand, are costs that have been incurred and cannot be recovered. Fixed costs affect the firm's decisions looking forward, whereas sunk costs do not. Fixed costs that are high relative to revenue cannot be reduced might lead to a firm shutdown. Eliminating those fixed costs and earning zero profit might be better than continuing to lose money. Incurring a high cost might later turn out to be a bad decision, but the expenditure is gone and cannot be recovered by shutting down. However, a prospective sunk cost is different and does affect the firm's forward-looking view. This is because a prospective sunk cost is an investment. Amortization. How do you deal with sunk costs? So think about like an airline buying a jet. Now, most airlines actually lease jets, but let's just assume they're buying a jet, right? The jet costs $1 million and they assume it lasts 10 years. The $1 million jet that lasts 10 years, you would want to amortize it. On an accounting statement, you're, instead of just showing money going out year one, $1 million, what the accountants will do through amortization is smooth that outlay over its useful life, that 10-year number. So effectively, the jet will show up as $100,000 depreciation expenses instead of a one-time hit. This makes the profits and stuff look more smooth instead of being lumpy with big expenditures in year one and then higher profits in subsequent years. It just gives a couple examples here. Because computers are similar, competition is intense, and the profitability depends on the ability to keep costs down. Most important are the costs of component and labor. So which are is that a fixed cost, variable cost, or a sunk cost? We'll revisit that in a second. Software firm will spend a large amount of money to develop a new application. The company can regroup its investments by selling as many copies of the program as possible. Pizzeria sunk costs are fairly low because equipment can be resold if the pizzeria goes out of business. So it has another use, right? So you see that right there, because it has other uses, right? That someone else could buy the pizzeria. Variable costs are low, mainly the ingredients for pizza and perhaps wages for workers to produce and deliver pizzas. And then it talks about the textbooks. Textbook is a sunk cost, right? You really don't get your money back. They make a new edition every year, so it's hard to resell them. Measuring costs, which costs matter. So this is continued here. What I'll point out here is you have the total cost, and the total cost is really a combination of the fixed costs and the variable costs. Here and here. Next, you'll see that as we increase the units we produce, our average fixed cost drops, right? Because think about, we're renting the facility. If you produce 1 million widgets or 10,000 widgets, it won't really matter. Your fixed costs go lower over time. So a good business that is scalable, probably has, decent fixed costs and low variable costs. So as you scale up, you get really efficient. A business with high variable costs, on the other hand, you know, could get pretty inefficient if you get too big. And my head here in the video is covering, let's see if we can move it. It's covering some of these numbers, but basically average cost drops as we increase the units. And that's because fixed cost is static. Marginal cost, that's the increase in costs resulting from the production of one more extra unit. Because fixed cost does not change as the firm level of output changes, marginal cost is equal to the increase in variable cost or the increase in total cost that results from one extra unit of output. And it says marginal cost is really a change in variable cost over change in quantity. Definitions here certainly show up in a later exam: average total cost, average fixed cost, average variable cost. Determinants of short run cost. The change in variable cost is the per unit cost of the extra labor times the amount of extra labor needed to produce the extra output. So because change in variable cost equals change in labor, this is the equation here. I will not quiz you on the equation, but it's good for you guys to know conceptually. The extra labor needed to obtain an extra output of the unit is change in labor over change in quantity. And this goes back to the concept of diminishing marginal returns and marginal cost. Diminishing marginal returns means that the marginal productivity declines as the quantity of labor increases. So why does, we've talked about this in class a bit. Once we hire a certain number of workers, we're going to lose productivity. Maybe it's because you lose your ability to manage effectively when you have a large number of people. Maybe it's because you don't have enough demand for your services and product, and labor gets wasted because you don't want to fire or have layoffs. As a result, when there are diminishing marginal returns, those will decrease. As a result, when there are diminishing marginal returns, I can't read that word. Sorry. In the total cost curve, as you see right here, is the vertical sum of the fixed costs and variable cost, VC. In average total cost is the sum of the average variable cost, AVC, and the average fixed cost, AFC. Marginal cost crosses the average variable cost and the average total cost curves at their minimum points. So you'll see that right here. The average marginal relationship. Marginal and average costs are another example of average marginal relationship described last chapter. Because the average total cost is the sum of the average variable cost and average fixed cost, the average fixed cost declines everywhere. The vertical distance between average total cost and average variable cost curves decreases as output increases. So basically, if you're just paying rent on this one warehouse and you create massive scales and operations, your costs of the facility are low. It's all the ingredients you need or materials you need to make whatever it is you're making that are really most of your cost. Total cost is a flow. The firm produces a certain number of units per year, thus its total cost is a flow. For example, some number of dollars per year. For simplicity, we will often drop the time reference and refer to total cost in dollars and output units. Knowledge of short-run costs is particularly important for firms that operate in an environment in which demand conditions fluctuate. If the firm is currently producing at a level of output in which marginal cost is sharply increasing, and if demand may increase in the future, management might want to expand production capacities to avoid higher costs. This is just an example about aluminum smelting, and how costs increase, the more output this is. One of the, there's only a certain amount of aluminum you can kind of pump through one of these smelting facilities with the man hours you have. So sometimes the reason for marginal costs increasing and decreasing marginal returns. Well, what if you have like 3 shifts, right? You have maybe like a 7 to 2, a 2 to 9, and then an overnight shift. That overnight shift, if you need a third shift, you have to pay those workers that are working overnight like a higher wage, right? For this is just talking again more about the aluminum smelting and how at a certain quantity they can produce at a certain price. But what happens is, they'll eventually hit a point where it gets less and less efficient to produce more. Like maybe the factory's too tight. Another example. The short run average variable cost of smelting is constant for levels of output using up to 2 labor units. When a third is added, which is like adding the third shift or the overnight shift, marginal cost and average variable cost increase until maximum capacity is reached because you're paying those workers who work the third shift, um, more money. User cost of capital. The annual cost of owning and using a capital asset equal to economic depreciation plus foregone interest. Um, so, if you were spending money on an asset and you spent $1 million, well, what could you have done instead? You could have took that $1 million, put it in a bank account, and you would have earned $50,000 in interest. You know, um, the user cost of capital is given by the sum of the economic depreciation and the interest that could have been earned had the money been invested elsewhere. So user cost of capital equals economic depreciation plus interest rate divided by multiplied by the value of capital. We can also express this as R equals depreciation plus interest rate. That will be a concept we'll have in a future exam. Cost minimizing, input choice. We can now turn to a fundamental problem that all firms face: how to select inputs to produce a given output at a minimum cost. For simplicity, we will work with 2 variables, labor and capital. In the long run, the firm can adjust the amount of capital it uses. The firm must decide prospectively how much capital to obtain. In order to compare the firm's expenditures on capital with its ongoing cost of labor, we want to express this capital expenditure as a flow, like dollars per year. To do this, we must amortize the expenditure, like I said before, spreading it over the lifetime, the expected useful life of that asset. And we must account for foregone interest that the firm could have earned by investing the money elsewhere. And as we said before, like a T-bill or a government bond. The price of the capital is its user cost given R plus the depreciation rate, and you can't see because my head's in the way, but it's plus interest rate. The rental rate of capital, cost per year renting 1 unit of capital. Think about renting a piece of equipment. If the capital market is expensive, the rental rate should be equal to the user cost R. Why? Firms that own capital expect to earn a competitive return when they rent it. This competitive return is the user cost of capital. Capital that is purchased can be treated as though it were rented at a rental rate equal to the user cost of capital. It's talking about an isoquant line, graph showing all possible combinations of labor and capital that can be purchased for a given total cost. Producing a given output at a minimum cost. So it shows you these iso cost curves, line A, or that's Q actually. Iso cost curve C is tangent to the iso cost quotient Q, and can be produced at a minimum cost with labor input L1, and capital K1. Other combinations L2, K2, and L3, K3 yield similar output but at a higher cost. Input substitution when an input price changes. Let's say you're a restaurant, you're making chicken and rice, chicken gets expensive, you switch to steak, right? Facing an iso cost curve C1, the firm produces an output Q1 at point A using L units of labor and K of capital. When the price of labor increases, the iso cost curves become cheaper. Output Q is now produced at a point B on the iso cost curve, C2, you see it's C2, by using L2 units of labor and K2 units of capital. So if one gets more expensive, effectively it gets swapped out, right? We talked about this with McDonald's. Labor gets really expensive. They'll start buying iPads to replace the workers instead. Recall that in our analysis of production technology, we showed that the marginal rate of technical substitution of labor for capital is the negative slope of the isoquant is equal to the ratio of marginal products of labor and capital. If it follows that when firm minimize costs of producing a particular output, the following conditions hold. We can rewrite this condition as follows. So, again, one way to really think about this is, if machinery is expensive, you'll use more labor, especially if labor is cheap. So think China, they actually have less automation in Japan because labor is so cheap, but Japan has a very old population. Labor is relatively expensive, so they lean more on automation or capital than labor. An effluent fee is a fee per unit that the steel firm must pay for the effluent that goes into the river. So effectively, this is a pollution tax. The cost minimizing response to an effluent fee: when the firm is not charged for the dumping of the wastewater, it's used to produce at a given output of 10,000 gallons of wastewater. However, an effluent fee raises the cost of wastewater, shifts the ISO cost curve, and causes the firm to produce at B. A process that results in much less pollution. So, basically what they're saying here is if you penalize pollution, theoretically, you get less of it. What about with varying levels of output? So expansion, path curve passing through points of tangency between a firm's ISO cost lines and its ISO quants. The firm can hire labor at $10 an hour and rent capital for 20. Given these input costs, we have drawn 3 of the firm's ISO cost lines. Each ISO cost line is given by the following equation. You can see that right there. The expansion path and long run costs. To move from expansion path to the cost curve, we follow the 3 steps. Choose an output level represented by an isoquant, then find the point of tangency of that isoquant and isoquant cost line. From the chosen ISO cost line, determine the minimum cost of producing the output level that has been selected. Graph the output cost combination. So if you're running a franchise or of McDonald's, you want to figure out hey, the giant iPad's 10 grand. It's probably easy math on replacing the workers, but hey, what should if we can get order entry done, for really 0 variable costs. Because think, those little iPads at McDonald's or ordering off your phone, 0 variable costs. It's one fixed cost. They develop the app and they maintain it. But, the variable costs on that are low. But, when you have labor, right, it's all variable costs, right? How many hours is so-and-so working? This is just showing the expansion path and the long run total cost curve. It illustrates the lowest combinations of labor capital for each level of output. Reducing the use of energy efficiency through the substitution or capital substitution for labor. Greater energy efficiency can be achieved if capital is substituted for energy. This is shown along the isoquant Q1 from point A to B, with capital increasing from K1 to K2 and decreasing from E2 to E1 in response to a shift in the cost curve. So again, if you make it, if we're gonna say we penalize car companies for not meeting efficiency standards in their engines, or we give them a less tax break if they don't meet these efficiency standards, that's going to increase their costs. So they'd usually prefer to do what? Right? Make their engines more efficient. Energy efficiency through technological change. So you think about one thing could be like light bulbs here, right? Light bulb used to last a couple of years maybe, but now what happens? We have these LED bulbs that will probably outlive us, and that's one way to increase energy efficiency. The inflexibility of short-run production. So in the short run, you can't change anything. In the short run, you can't lower costs. You can't hire and fire workers. They're probably on like some fixed schedule, fixed hours. So it's very difficult to change things in the short run. Long run average cost curve. The ability to change the amount of capital allows the firm to reduce costs. The most important determinant of the shape of the long run average cost and marginal cost curves is the relationship between the scale of the firm's operations and the inputs required to minimize its cost. Well, if you're working for, like a software company, it might not be like fixed costs because once you have the software developed, you have it, right? Not a lot of variable costs compared to like a home builder, where it's probably all variable costs. Like, hey, are you buying the equipment and have the labor to build the home? Short run average cost curve related to the average cost of production to output when the level of capital is fixed. And then the long run marginal cost curve showing the long run cost curve total as an output is increased incrementally. When a firm is producing at an output at which the long run average cost is falling, the long run marginal cost is less than the long run average costs. So just to explain that concept one more time, when the firm is producing an output at which the long run average cost is falling, so long run average cost is falling, that means your marginal costs or variable costs are getting lower with scale. And speaking of scale, economies and diseconomies of scale, if the firm operates on a larger scale, workers can specialize in the activities at which they are most productive. Scale can provide flexibility, combination of inputs can be utilized, managers can organize the production and process more effectively. The firm may be able to acquire, inputs at larger qualities, getting them at lower prices. Number 3. At some point, however, it's like the average cost of production will begin to increase. Hey, maybe your workers unionize, right? Or or there's a tight labor market, or the materials you use get more expensive, right? There can be a whole bunch of things that can change, right, and bring up costs. Economies of scale and diseconomies of scale certainly show up in our next quiz. Situation in which output can be doubled for less than a doubling of cost. Diseconomies of scale, situation in which doubling of output requires more than a doubling of costs. A firm enjoys economies of scale where it can double its output for less than twice the cost. The term economies of scale includes increasing returns to scale as a special case, but it is more general because it reflects input proportions that change as the firm changes its level of production. So, in my firm, I told you, there's certain, I'll probably lose like $30,000 to $40,000 in costs as I get bigger. So, right now we're at economies of scale, right? But at some point, I take on too many clients, I'm too busy, and it works the other way, right? Then I'll have diseconomies of scale. So usually this fluctuates with the business over time. Economies of scale are often measured in terms of cost output elasticity. That's a percentage change in cost of production resulting from a 1% increase in output. So this is simply another elasticity formula, right? Change in cost over change in quantity. Just another elasticity formula, really easy to remember. Effective effluent fees on input choices. So talking about electric cars, and this is a little bit dated because they're talking about bring out like the Model 3, which is widely available today. And they're talking about how to bring down those costs. And Tesla's thinking is if they build more batteries, they can drive down costs, bring down costs of the electric car, right? So, but if they only produce a few batteries, then their costs are really high. This is why Tesla started with more kind of sports cars, and they used that business to fund all the lower end stuff eventually. The relationship between short run and long run costs. The long run average cost curve is the envelope of the short run, right? So basically, long run costs are an aggregation of all your short run costs. Product transformation curves. Product transformation curves showing the various combinations of two different outputs that can be produced with a given level of inputs. So what can you produce, and how do you produce it? Economies of scope, diseconomies of scope, and degrees of economies of scope will certainly be on a future exam as well. Situation in which a joint output of a single firm is greater than the output that could be achieved by two different firms. So, basically they're more efficient, having a merger. And then diseconomies of scope, in which joint output of a single firm is less than what could be achieved by two separate firms. So diseconomies of scope is a situation in which competition is better. And then all this happens on degrees, right? There's no pure case. And as I mentioned, with my firm, it's like, yeah, we have economies of scale now where we're small, but as we get bigger, we lose that. The best businesses can keep economies of scale, growing. Economies of scope in the trucking business, um, you know, because large firms carry sufficient truckloads, there is usually no advantage to stopping at an intermediate terminal to fill a partial load. Because other disadvantages are associated with management of very large firms, economies of scope get smaller as the firm gets bigger. The study suggests, therefore, that to compete in the trucking industry, a firm must be large enough to be able to combine loads at intermediate stopping points. So basically, they need to be able to kind of move goods and services around efficiently, and be able to move things at a low cost by, doing good routes and things of that nature. The dynamic changes in cost, the learning curve. I kind of summed this up at the start of this little class here. Effectively, workers often take long to accomplish a task. The first few times they do it, they get better as they do it more. Managers learn to schedule production more efficiently over time. Engineers are usually cautious and they get more confident. And suppliers may learn how to process required materials more effectively. This is all coming down to the learning curve, which will also certainly be a topic that's covered in our next quiz. And here's a visualization of the learning curve. Initially you might have like no output, working a lot of hours, and then you're working, your output per hour, increases dramatically as you know how to do your job. Learning versus economies of scale. A firm's average cost of production can decline over time because of the growth of the sales when increasing returns are present, or it can decline because there is a learning curve. So if you hear like, hey, a company just decided to outsource its entire sales department to another organization, maybe it takes that new organization a year to get up to speed on how to sell that product or learn that product. A firm's producing machine tools knows that its labor requirement per machine for the first 10 machines is 1. The minimum labor requirement A is equal to 0, and the beta is approximately 0.32. This calculates the total labor requirement for producing 80 machines. And just a good visualization, right? Like there's a lot of different ways we can kind of put this together depending on the level of output we want to achieve. Learning curve and practice can be important in determining the shape of your cost curve. If everyone in your team is really up to speed, you'll be efficient. But if everyone on your staff is new, you won't be, right? Your costs are higher when you're inefficient, is the overall concept here. The learning curve relates to the labor requirement per aircraft to the cumulative number of aircraft produced. So, you might start out like your first, you guys see the Sphere in Las Vegas. That was very complicated to build, took a long time. But they're supposed to build like 6 more of these things. And when they build the second and third one, they're going to get built a lot faster. Why? They've already built one. Cost function relating the cost of production to level of output and other variables that a firm can control. So there's just a good visual of like who has higher variable costs versus the quantity of the cars. To predict costs accurately, we must determine the underlying relationship between variable cost and output. The curve provides a reasonably close fit to the data, but the shape is the most appropriate. And how do we represent the shape algebraically? This would be it right here. Variable cost equals beta times quantity. Cost function in the measurement of scale of economies. Scale economies index provides an index of whether or not there are scale economies, meaning, you know, if you, have more product to sell, do you make more money, right? And if you double your output, does your cost double? If not, then you probably have economies of scale. And this is just talking about a cost function for an electric power plant. Was this due to increase in economies of scale or other factors when it talks about the differentiation and power output? It would be economically efficient for regulators to break up an electric utility monopoly. So why are some utility companies monopolies? Well, because it's more efficient to have them as a monopoly, and it would be more costly to the consumer to break them up. Average cost of production in an electric power industry. So the average cost of electric power achieved at a minimum approximately 20 billion kilowatts by 1970. The average cost of production had fallen sharply. And again, you get economies of scale, your labor gets more efficient, better educated. This is the appendix to chapter 7, so we'll stop here. I will see you guys on Thursday, and thanks for watching.